This is Physics 2211, Lab 5, where we'll be examining a collision. So the goal of this lab was to observe the collision between two identical pool balls and use the principle of conservation of momentum to analyze the velocities before and after the collision and then find the loss in energy from the collision. So in this lab, we found that even though momentum should be conserved, um, there is a loss in energy from, it could be from the felt on the table or, something else. And so, yeah, we'll get right into it just a second. So before we get into it, we're going to look at some key concepts. And so we'll look at the conservation of momentum. So momentum is defined as mass times velocity. And so momentum before the collision and momentum after the collision should be the same. So what you see right here um, is what I'm talking about. So we can translate that into M1v1 equals M1v2 plus M2v3. And then another key concept is going to be our change in energy, which in this system we're just going to define as kinetic final minus kinetic initial. And so we can just make this equation right here, and we'll calculate that after the video. And so here's our video. So as you can see, the red ball, it's the yellow ball, and the momentum is transferred into the yellow ball, and the red ball still has a little bit after the collision. So here are the graphs, and so as you can see in these boxes where I drew, that's where I calculated the velocity of the balls for before and after the collision. So this is going to be the red ball, and so the velocity before was negative 0.72 meters per second, and then after it's negative 0.175 meters per second. And then here in the yellow ball, I chose this kind of section of data because it was kind of the most even after the collision. See, it's kind of jagged up here. And so from that, I got negative 0.425 meters per second. So the yellow ball is moving faster than the red ball after the collision, but they're both moving slower than the initial velocity, which is expected. So here's a mathematical analysis of the conservation of momentum. So we calculate the initial momentum and the final momentum. And so when we do that, we find that they are not equal. So there must be some discrepancies, likely friction. It could be the fact that I chose data points for the yellow ball to be later in time. So they are pretty close, but they are different. So now we'll look at the change in energy. So I actually found that there was a loss of 0.026 joules from the collision, and that could be from friction, or it could also be from the red ball. As you can see, actually moves up a little bit after the collision, and so we didn't calculate for that, and that could also be a source of error, or a source of error in the change in momentum. So now to conclusions. What if question. What if one of the balls was greater in mass than the other? So if the red ball was greater in mass, and the initial velocity was the same, the overall momentum would be greater. Since to find momentum, you're multiplying by mass. And so the final momentum would also be greater, and the final velocity of both the balls, or at least the yellow ball, would be greater. If the yellow ball was greater in mass, the overall momentum would stay the same, but the final velocity would be less. So Now, what does it mean? What does it mean that the balls lose energy after the collision? The balls lose energy because it could be the friction on the table, or some of the energy is directed upward, which I did not calculate. So that's also a reason for a loss of energy. And that's it.